Many astronomical discoveries have completely changed the way we view our universe. Astronomy is constantly evolving as scientists explore new and uncharted territory in space. In recent years, there have been some amazing discoveries made in the field of astronomy, and as astronomers learn more about our universe, the latest findings are constantly making headlines. So, today, here at Unexplained Mysteries, we'll be taking a look at 3 incredible astronomical discoveries. Telescopes detect the biggest explosion since the Big Bang. In a recent development, astronomers have discovered the largest explosion since the Big Bang. The explosion resulting from a massive black hole occurred at the center of the Ophiuchus galaxy, about 390 million light-years away. This blast is not just speculation from eager scientists. NASA was able to confirm the blast because the radio data and X-rays matched each other, and low-frequency radio telescopes found that the cavity was filled with radioplasma. While scientists have long been interested in the Ophiuchus galaxy due to its strange curved edge, there had been plenty of doubt about if this curve could have been caused by a black hole. Black holes can release vast amounts of material and energy as radio jets that collide with other objects in the locality. Despite the black hole theory, many astronomers actually believed that the cavity was too big to be a black hole. The team who discovered this incredible event are researchers at the International Centre for Radio Astronomy Research in Western Australia. The team used 4 telescopes for their work, each stationed in different parts of the world, including the European Space Agency's XMM Newton X-ray Space Observatory and NASA's Chandra X-ray Observatory. The explosion was so large that it cut through the hot gas that surrounds black holes, called cluster plasma. According to Melanie Johnson-Hollett, a professor at Curtin University and co-author of the research paper, we've seen outbursts in the centers of galaxies before, but this one is really, really massive, and we don't know why it's so big. The nature of this massive explosion has drawn comparisons to another destructive, large explosion right here on Earth, the 1980 eruption of Mount St. Helens, which destroyed about 200 square miles of wilderness. Despite these comparisons, the crater the eruption created could fit 15 Milky Way galaxies in a row. Another interesting aspect of this explosion is just how slow it occurred. According to Johnston-Hollett, the explosion looked as if it had been slowly happening over hundreds of millions of years. Excitingly, this discovery may have made it possible to find more outbursts in the future. Astronomers are now able to use low-frequency radio telescopes that may make it possible to discover more explosions like this one. Scientists are realizing that a mysterious, fast radio burst from space looks strangely familiar. In the galaxy M81, 12 million light-years away, scientists saw strange, bright flashes that are drawing up memories from flashes found in the Crab Nebula. The Crab Nebula is a famous remnant of an old supernova that humans witnessed all the way back in 1054 AD. Those flashes, now known as repeating fast radio bursts, or FRBs, were seen by multiple different cultures, such as Chinese astronomers who saw the star above the southern horn of Taurus, as well as Arab and Japanese astronomers. The flashes remained brightly shining for 23 days and were 6 times brighter than Venus, according to the astronomers at the time. It took 700 years for the star remnant to be spotted by telescope by John Bevis, a British astronomer. Famous astronomer Charles Messier even found the star 27 years later and included it in his catalogue of Messier objects. Then, another 200 years later, in the 1960s, astronomers detected a fluctuating radio source where the Crab Nebula lies and determined that the signal came from a pulsar or a neutron star with a strong magnetic field. Now, the flashes that were recently detected by scientists are being compared to those witnessed 1,000 years ago. According to Kenzie Ninmo, a PhD student in astronomy, some of the signals we measured are short and extremely powerful, in just the same way as some signals from the Crab pulsar. Astronomers are still trying to figure out the nature of fast radio bursts because where they were found is quite peculiar. Usually, FRBs are found in galaxies abundant with young stars, but the radio dishes pointed the signal's source to a group of old stars called a globular cluster. The source of the signal challenges the idea that magnetars, the strongest magnets in the universe and a type of supernova remnant, are responsible for FRBs. This is because the explanation works well when young stars are abundant, but when there is a substantial number of old stars, as is true for galaxy M81, the explanation begins to make less sense. Some astronomers, however, believe it's possible that the magnetar was created by a white dwarf that pulled gas away from another nearby star. The added mass may have caused the dwarf star to turn into a magnetar. Whatever the explanation of the fast radio bursts in M81, astronomers believe there is definitely something strange going on. As time passes, hopefully, answers begin to come in. DARPA launches OUJI project to study radio signals. The US military has revealed its interest in learning about how radio signals function in Earth's atmosphere, as a new program called OUJI, set up by the Defense Advanced Research Projects Agency, will be using sensors on low-orbiting satellites to track these high-frequency radio waves in the ionosphere. The OUJI program is most interested in the ionosphere area, about 125 to 185 miles in altitude. The area lies in the middle of our planet and the International Space Station, which sits at about 250 miles high on average. The military has good reason for their interest in these radio waves, because producing signals in the ionosphere is rather unpredictable due to an extensive amount of charged particles that can alter the path of the radio signals. Making the study of radio communication even more difficult is how the ionosphere's density can even be altered by solar activity. Interest in studying radio waves in the ionosphere has been around since the 1950s, when multiple organizations, such as the Institute of Radio Engineers, acknowledged the ionosphere's effect on radio waves. In fact, satellite studies into this matter have been ongoing since 1957. DARPA's plan to investigate the ionosphere's effect on radio signals is split into two research areas. They are planning to first deliver small satellites to orbit and measure the density of electrons by both directly sampling and indirectly using navigational satellites. The second area of the plan is creating a density model for electrons and then validating the model with on-orbit data. Another challenge DARPA will need to overcome is creating a high-frequency mission payload with a range of frequencies as well as low noise. While antennas in the type of work they are doing are usually long, a long antenna might create a drag in the lower part of the atmosphere and will be harder to deploy in space. Due to these factors, more planning will need to take place, but DARPA's interest in this issue highlights how astronomical discoveries are essential, not just for abstract knowledge, but for tangible goals that affect our everyday lives. But what do you make of these incredible discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.